I love being in London, and I've already been here a few days, which means I'm about 110% tea and 0% regrets. And I'm just so ready to just vibrate at you for 40 minutes. But before we start, allow me to just say, Happy Pride. Yes. See, I knew you were a hip crowd, and for those of you that don't know what I'm talking about, it's like the World Cup for people with fashion sense. So. This talk is called the Container Operator's Manual, and if you have any comments or critiques, want to talk about how rad my shoes are, because they are, my Twitter handle is right up there. It's at Alice Goldfuss, and I'm very excited to hear what you have to say. Speaking of me, who am I? I'm Alice. Nice to meet you. I'm a site reliability engineer at GitHub, which means I'm a professional warrior with sudo access. And today I want to talk to you about car ads. Now, you know when you're watching TV, and by that I mean the 5 seconds before the skip ad button comes up on YouTube, and it's this car ad, and it opens up on this beautiful, picturesque mountainside of this serpentine road weaving in and out, and there's this sleek beast of a car raging down the countryside, and all these stats are popping up on screen, like 0 to 60 in 3 seconds, 70 miles to the gallon, 5-star rating, and you're watching it like, yeah, this is amazing. Science has proven that this is the best car ever made. I must buy it. I must have this car in my life. And if you watch really closely, you may notice at the very bottom of the screen in really small letters, you may see the phrase laboratory setting. Laboratory setting, because it's an advertisement. And those stats and figures were gathered in perfectly tuned laboratory conditions. They're about one step away from theory, and if you were to purchase that same car and take it out into the field, you would not get the same results. And that's how I feel about most container talks. You walk into a container talk, you sit down, and they go, step right up, step right up. In the next 15 minutes, I will tell you everything you need to know to completely revolutionize your infrastructure. What's that? You want to run more than one container? Well, no problem. Just download this gist, don't read it, run it on your laptop, and in 5 seconds, you will have a perfectly tuned 3-node cluster running. And you want to run containers in prod? Well, go right ahead. After all, prod is just your laptop times 100, right? Great, and then they walk off. And you're left staring at this half-finished tutorial like, is this why sysadmins are so mad? Frankly, I would like to see a lot less Docker 101s and a lot more Docker WTFs. Because there are just things, as an industry, we need to talk about when it comes to containers. We need to examine them a little more critically than what we've been doing already. And that's what I want to do with you today. I just want to discuss some of my experiences with you to help you make better decisions when it comes to containers. And you might be saying, all right, great, that sounds good, but why should I listen to you, Edward DevOps Hands? Well, this is what I've been up to. I first started running containers in prod at scale in January of 2015. And that was at a company that looked at Docker 0.6 and was like, yeah, let's run it in prod. And we did. And we kind of just paved the street behind us. So a lot of good early adopter information from that experience. And from there, I went to a team that built and maintained Dockerized Cassandra clusters. And now I'm on the team that runs the Kubernetes platform behind GitHub.com. So all told, I have about 3.5 years experience running containers at production scale. And if you consider Docker came out about 5 years ago, that's really not bad. But before we begin, I want to make sure we're all on the same page. So let's just start with, what is a container? Because if you've ever been to one of those Docker 101 talks, it usually goes a little bit like this. First, you have your host, and it's a box. And on top of your host, you have your operating system, which is also a box. And on top of that, you have your container daemon or engine, and it's a box. And on top of that, you have your containers in little boxes. And that's fine, except it's all lies. It's just completely wrong. It's just led you to deception. And this is a really good way for humans to see containers, but this is how your computer sees containers. So this is the output of a top command from a Kubernetes host. And as you can see, we have some processes running. Third down, we have the Docker D process, which is that Docker daemon or container engine. Fifth down, we have a kubelet process, which is a Kubernetes process. And then we have some Ruby and Python processes running. And those Ruby and Python processes are containers. Those are containerized applications. They're not abstracted away. They're not hidden in boxes. They're just processes. Because containers are processes born from tarballs, anchored to namespaces, and controlled by C groups. So what do I mean by that? There is no actual concept of a container in the Linux kernel. There's no flag that you trigger to use a container. Containers are made up of a bunch of native Linux features stapled together. So let's break that down a little bit more. When you're making a Docker file or some sort of container config, you are specifying a recipe or instruction set for the environment and file structure of your application. And when you build that Docker file, you are making a tarball. And when you deploy it, it gets deployed, unpacked, and run as a process, like any other process on that host. And here's where the native features come in. So the first feature is namespaces. Now, Linux namespaces determine what that process can see, such as other processes or directories, what have you, whatever you specify. It can't see everything on the host. It can only see its own slice of the universe. And we also have C groups or control groups. And C groups determine what that process can use, resources like memory or CPUs. And together, these features make containers. This is a container. And if you're going, oh, that's what they want me to run in prod? I thought it was like little whales or something. Don't worry, it's okay. We're going to take a nice hard look at containers, discuss some of the pros and cons, and enable you to make better decisions about whether or not this is the solution for you. And we're going to do it using 4 lessons. Could have been 400. I cut a lot out of this talk, but just 4. Put some tea in me, and I'll shove more at you, but just 4 for now. So let's start it off with the first one: containers have strengths. I don't want you leaving this talk and going on Twitter and being like, that emo kid doesn't like containers. Containers are good. I like containers. When they're used in the right way and when you play to their strengths. And containers' strengths lie in ephemeral, disposable processes. And by that I mean stateless applications. Now, just again, so we're all on the same page, what is a stateless application? A stateless application is an application that takes data in, changes it in some way, and then sends data on to another endpoint. And it doesn't keep any of that data for itself. It doesn't become altered by the data. It doesn't tick a counter or anything. It has no recollection of having processed that data. It is stateless. And stateless applications are fantastic when you are scaling out your infrastructure, because you can run multiple instances side by side and say, put them behind a load balancer, have them all pointing to the same backend like a database. And if one of those instances dies, your dependencies don't care. They still have things receiving data and things sending data to them. And the other instances also don't care, provided you have enough headroom, because they don't depend on each other to do their work. They are stateless. And this, if you lose that instance, no one cares. They're ephemeral, they're disposable. And containerizing things in your infrastructure that are already stateless, like if you have microservices, will really play to their strengths. And just so we're clear here, containers are not magic boxes, all right? My magic boxes are okay because we know they're lies. I'm going to use boxes to represent containers, but we know they're lies. But if you containerize stateless things, you'll be able to maximize those strengths. So what do I mean by maximize those strengths? Well, first of all, you make your applications portable. Once you go through that journey of making sure you have every dependency you need delineated out in your application file, and you've taken stock of everything you need to run them, as long as that container will run somewhere, if you have a kernel that'll handle it, you can run that application everywhere, and you don't have to worry about not having the dependencies that will support it. If you want to change the library versions in your config, you want to try a different version of your code, fine, rebuild it, deploy it, it'll be fine. And this means it's extremely easy to iterate, and it's extremely easy to upgrade. And you want to be able to iterate fast because we're all about innovation these days, right? All about that velocity. Containers can help you there. You change one thing, you could do A/B tests even. Change it, deploy it, doesn't work, change it again, redeploy it, you're all done. Now, you can get the same information on a blog post. You can get the same information from one of those Docker 101 talks. But a strength that those blog posts and those talks don't discuss is disaster recovery. How many people here have had to deal with disaster recovery? Yep, a few people. Yeah, so when you start hearing phrases like enterprise or legacy or SOC 2, you need to deal with disaster recovery. And how many people here have done a disaster recovery exercise that looks a little bit like this? Yep. You're sitting down, you're taking stock of everything you need to know to run that application for your disaster recovery process, and it turns out that this one uses Capistrano, that one uses Jenkins, this one is running a cron job off someone's laptop that deploys every day at 3 a.m., and if they were to quit, we'd be in big trouble. Theoretically, of course. And even though you write everything down and you think you know how to run your application, the day of the disaster recovery exercise, it turns out that you actually didn't have everything that you needed, and you have to call someone up to come sit with you and show you how to deploy their apps. But if everything is containerized, everything is deployed the same way to the same place. And as someone who has been on either side of the Capistrano world and the container world, I like it a lot better over here for a disaster recovery exercise. It goes so much slicker and so much cleaner. And this is also great when it comes to production incidents, when you're dealing with on-call. Say you get paged, and you wake up, and you look at things, and you're like, oh, it's actually not my service, it's someone else's service. Well, in the old world, you would have to page them and have them wake up and look at it and then redeploy their app, whatever arcane magic they use to do that. But if you are using containers, the first thing you can try is just redeploying their service for them. And if that doesn't work, page them. But it's possible that a redeploy is all is needed to kick it back into shape. And if so, you have just solved your incident in less time without having to involve more people. And that is a huge benefit. But even if you don't have a production environment, you can benefit from containers with testing environments. Because what are testing environments if not ephemeral spaces where disposable things run around all the time that you want to clean up afterwards? You could try all different versions of your application, your code, in different spaces, and afterwards, you can automate the build-up, deployment, and tear down. And if you want to keep the results in a centralized location, you can export them to a database or send them off somewhere else for later analysis, and then everything is cleaned up afterwards. And this is a fantastic way for testing customer bugs, by the way. You know when customers write in and they're just like, something's broken, and you don't download anything at all to match their environment, and you're like, can't repo, whoops. Well, now you can repro, not on your laptop, in prod even if you want to, on some other service, and you can test it using containers. This is fantastic if you, for example, work on a desktop application and your production environment is someone else's computer, but you still want to be able to test things fast. You can use containers to do this. Basically, anywhere in your infrastructure that you have ephemeral, stateless applications or services, you can strengthen them using containers, and I encourage you to do so. Now, if containers have strengths, it makes sense that they would also have weaknesses. And if container strengths lie in ephemeral, disposable, short-lived things, then surely their weaknesses lie with things that keep their state, keep their shape, are moldable. And by that, I mean stateless applications or stateful applications. And usually when people talk about stateful applications with containers, they want to talk about databases. They're like, oh, I attended one of those Container 101 talks, and now I'm going to containerize all my databases. And usually when they say that to me, I respond, are you Google? And that tends to hurt some feelings. Because when I say, are you Google, they usually hear, are you a success? Are you a household name? Have you had a lot of lawsuits lately? But what I'm actually saying is, are you routing billions of requests to thousands of databases across dozens of data centers per second? Usually, the answer is no, in which case, you really don't have to containerize your databases. But I understand why people want to. I totally get it. There are so many benefits, at least from the outside, of containerizing your databases. Faster provisioning, better stability, faster recovery. If you have a database team, if you're running databases on bare metal, and a dev team is working on a new service, they need a new database for that service, it could take the database team months to give them that database. They may need to put in a hardware order. They need to wait for that hardware to come in, get racked, get provisioned, apply the correct schema before they hand it off to the development team, and that slows down velocity, that slows down shipping. And so I totally understand why people would want to containerize databases. But you know what? You get all of these benefits from a cloud provider and some tooling. And people tend to think, well, do you have any idea how much that costs? That's so expensive. The AWS costs alone are just unbelievable. No, we were going to build our own solution. Well, how much do you think it's going to cost for your engineers to research, build, and maintain your own internal solution? And how are you going to ensure that they are going to properly treat your data the way you need it to be treated? Secure it properly, make sure it's archived properly. You're going to be dealing with a lot of data at the end of the day. And do you really want to build your own solution to handle that? But people say yes, and there are two main ways they go about it. So let's just discuss those two main ways. So the first way is you have some containerized database instances, and they send all of their data to some network-backed storage array like Ceph. And if one of those instances goes down, everyone's fine. You don't lose state. And you can redeploy or regenerate that database instance. It gets its state for something like etcd, and it keeps sending data back to the array. And this is fine, except you're sending data through the network means eventually you will be network bound. I mean, if you're gonna start doing like dedicated fiber for your databases, you might as well go to the cloud. Another way people do it, the second solution, is they have containerized database instances on hosts, and they store their data on the host using a mounted volume. And in this case, if you lose one of those database instances, the data stays behind. Well, now what do? Well, you can just redeploy that containerized database back to the same host. And if you recall, I said that I ran Dockerized Cassandra clusters. This is what we did. From the outside, it looked like a normal Cassandra cluster where you had one database per host. We weren't really winning on hardware footprint. Having the JVMs containerized allowed us to upgrade easier, deploy easier, but we also had to write a lot of our own tooling, and we still had to spend just as much on hardware and operating costs. So did we really gain anything? Other people may try to do this on a one-to-one basis where it's one container instance per host, and if they lose an instance, then they regenerate it elsewhere. But you still have to move that data. And once again, you're going to be network bound. But I know people want to containerize their databases. And if you're going to containerize databases, my only advice is keep it small. Keep it small. Keep your footprint small. If you want to do a test database, if you want to do some sort of assets database that maybe has 5 gigs on it, fine. But don't store your 16 terabyte customer account database in containers. It's not going to work. You're going to be sad. Or, again, use a cloud provider. I was taking a look at the features the other day, and both AWS and Google Cloud allow for automatic database failover. They have scalable databases, you have automatic read replicas, and it covers multi-regions. And Azure has the exact same set, except instead of automatic failover, it's manual. They're currently working on automatic. This gives you everything you need without having to worry about if you're going to be network bound, without having to worry about if your engineers are going to be securing your data properly. I would highly recommend this route. Speaking of vendor solutions, that brings us to lesson number 3, which is containers need friends. People start looking at containers and they're like, oh yeah, we're gonna do containers. Gonna slap some containers on that. We're looking into containers now. Very hot right now, those containers. But the thing is, it's never just containers. Containers these days is a vast ecosystem of different vendor solutions, and you need to look at them, research them, and glue them all together to get a container platform. For example, what are you going to use to build those container tarballs locally? You could use Docker. It's basically primed for a dev setup, but you don't have to use Docker in production. You can run those containers with something else in prod. Do you want to do that? You should research that. Orchestration. How are you going to schedule your container resources? When you are deploying those containers to your platform and it says, I need this much memory, this much CPU, what are you going to use to decide where to run that container? Which host to put it on? What's going to be making those decisions for you? How are you going to automate it? Management. Let's say you want to run clusters on your container platform. Well, what are you going to use to do health checks or to drain traffic or to do automatic failovers? How are you going to do that sort of management? And last but not least, networking. You are adding a completely new abstraction layer to your infrastructure. Now that you have a bunch of containerized services running, how will you handle routing both internally and externally? How will you handle access control? Can all the containers just talk to each other, regardless of if they need to? And how will you handle service discovery? How will one container find another? You're going to need to figure that out. And just to give you an example of how much you're going to be looking at, this is just a handful of software solutions out there that handle networking in Kubernetes. And they don't all do the same thing. You need to use multiple of these in order to get a complete networking solution. And for each of those, you need to ask yourself, what is the rate of adoption? Do we think it has long-time support? Do our engineers already perhaps know people that work on those projects? Do our engineers understand what these projects are doing? Can we possibly contribute upstream if it doesn't do exactly what we want? Did we already try to run it? Do we understand it? Does it work? You're going to need to do a lot of research. But let's say you did your research and you figured out what you need to do and you have containers. You have a container platform. Great. Now you have to hook it into your already existing infrastructure. For example, deployment. How are you going to deploy to your new container platform? Is it the same tooling as you're currently using to deploy? Do you have to change it in some way? And how are you going to support 2 parallel deployment pipelines of your legacy applications and your container ones? And where will support go if one of those pipelines breaks? Where's your priority? How will you handle deployment? Monitoring. What new metrics and data points do you need to be monitoring on your container platform? What counts as a healthy container? What counts as a healthy service now that you're probably running more than one in containers? Does your current monitoring support this? Do you need to build new tooling or get a new vendor solution that'll handle that monitoring for you? And do you have to train people on how to use it now? Provisioning. How are you going to provision new container hosts? Do you need to update your base images? How will you handle inventory concerns? What gets priority, container hosts or legacy hosts or database hosts? How will you make sure that you have enough inventory to go around to build out your container platform? And last but certainly not least, debugging. Now that you have this brand new layer of abstraction, how are you going to troubleshoot it? What do you need to know? And aside from the team that is currently owning and operating this container platform, how will you empower the other developers running services on your platform to troubleshoot their services? Are you going to make some sort of centralized logging platform? Are you going to make your own tooling to make it easier for them? Do you have to offer training? How are you going to make sure that they can take care of themselves now that they're running on something new? And between having to research the container platform, having to integrate it with your new infrastructure, you are going to be looking at a gradual rollout where you try some things, you fail, you try some new things, they're steady, you try to migrate apps, that fails. And because of this, you're looking at a minimum 1-year span to get a container platform off the ground. And when I say off the ground, I mean you have a container platform, it's mostly stable, and you have like one service running on it. 1 year to get there. And by the way, the end goal for containerizing is usually not everything is containers. You're usually going to be dealing with a hybrid solution where you have legacy apps, such as databases, running the way they always have, and then some of your services are containerized. This has been true of everywhere I've worked. Most places that are containerizing already existing applications are looking at something like this as a final state. And you need to understand what your end goal is and set your expectations accordingly. And know that it's going to take you a while. This brings us to our last lesson. And if you ignore everything else in this talk, if you're just like, yeah, I'm going to containerize my databases right now, I'm going to do it on my phone, fine, whatever. There's enough semaphores on there, it'll be good. No. Please pay attention to this last lesson, which is containers need headcount. If you want to fail at containers, just ignore this slide. Because usually what happens when people want to do containers is some conversation happens behind closed doors where one person says, we need containers, and the other person says, let's give it to ops. After all, ops already owns inventory and provisioning, configuration management, network, deployment tools, monitoring, incident response, possibly even your databases. So let's just put containers on top of that. Because containers are, what, that's like Jenkins, right? Like it's just like using a new Jenkins. No, it is not like using a new Jenkins. Looking into rolling out a container platform is not like using just one piece of new software. It's like deciding to build a new data center in a city no one has ever heard of, with hardware no one's ever used, and software no one's even touched. It is a completely new can of worms that you are going to need time and research to handle. And so you are going to need to build a new team, a completely new team you're going to need to hire to build this container platform. And you're going to need a select number of skills in order to make this team successful. So here are some of the skills that you should be hiring for to empower this new team and make sure that it builds container platform correctly. You're going to need someone who understands operations, perhaps even someone who understands operations at your company. And yes, this is the one time when you can move someone from ops to this new team, but then you need to backfill them. You can't just take them away permanently. They need to be backfilled on their old team if they're joining this new team. But you need someone who knows ops at your company, because they're going to need to know where the skeletons are buried, where the snowflakes are running, because the hope is eventually they will be containerized and migrated over. So you're going to need someone that knows that. You're going to need someone who knows deployments, how deployments are handled at your company, and has a pretty good vision for how to integrate containers into that deployment pipeline. You're going to need someone who can write and test the tooling that you will need to glue that container platform together. Because even after you figured out what vendor solutions you're going to be using, more than likely, they're not going to give you everything you need. And then you also have to integrate it into your already existing infrastructure, and you need someone who can build that tooling. You're going to need someone who understands monitoring, who has a good eye on what kind of new metrics and data points and health checks you're going to need for your new platform. You know that person where someone in Slack is like, I don't know, something might be broken, but I can't tell. And 5 seconds later, someone has dropped in a brand new dashboard they made that shows, yes, the thing is broken. You need that person. That's the person you need. You need someone who understands the kernel, because you are going to get some interesting low-level interactions between containers, your infrastructure, and your kernel. And you need someone who can, say, analyze kernel crashes, take a look at what's happening upstream, and understand those odd spaces between things, someone who can look at the lower level. You're going to need someone or someones who understands networking and can make solid decisions for what you need to do for your new platform network. Because again, there are a lot of different choices out there. You're adding new levels of abstraction. You need someone who understands how that's going to integrate with what you're already using and what's going to be best for your architecture. You're going to need someone who understands what security containers provide out of the box, what they don't, and what best practices in the community are. Containers have kind of a bad reputation when it comes to security, but they've made great strides in this area, and you need someone who's passionate about that, who can do the work for you, because a lot of times security in containers is very last of the list when it comes out to rolling out a platform, and it should really be a first-class citizen. You need someone who can help with internal adoption, who has good relationships with other teams internally, because you're going to need someone that can walk up to them during their stand-ups and go, "Oh, that's a nice roadmap you have. You know what would be better is if you didn't do that and instead containerized your services and put them on our beta platform and get all bugged out and then tell us what's broken. That would be great." You're going to need that person that can manage those relationships, because you need those beta customers in order to build a more solid platform. And if you don't have that early adoption, your platform is not going to succeed. So you need someone that can help you with that migration internally and get it rolling and manage those relationships. And last but not least, you're going to need someone who can keep the project and the team on track and get the support the project needs internally to succeed. There are a lot of obstacles that are going to come up when you're trying to roll out a container platform. People might start yelling at each other over roadmaps, don't know why that would be, and you're going to need a project manager that can step in and go, no, it's fine, we'll give you what you need. My team needs to go over here now, what are you doing? And then just keep them on track and boost morale when things don't work, because again, you're going to be going through that research phase, that development phase where things are probably going to fall on the floor and shatter. And you need someone that could be like, that's fine. We padded the roadmap for this. We know the timeline we're dealing with. You're fine. Go pick something else to try. Now, each of these skills doesn't need to be a dedicated person, but it also can't be just one person. Okay? You need a team. Ideally, your team should be between 6 to 8 people. But it at least needs to be 4 people. And that's because eventually this team will be on call for this platform, and an on-call schedule of less than 4 people is, in my opinion, untenable. Don't do that to your engineers. They will burn out. So at least 4 people, but I would do at least 6 to 8. And you need to empower them to succeed. And this is more than just that project manager's job. You are going to need authority. You're going to need top-down authority in order to build this container platform, because they're going to be trying new things. They're going to need a budget, for example, to try out cloud instances, to iterate faster. They're going to need the mandate to mess with other people's roadmaps to help with that migration. They're going to need the space to fail. And you need to make sure that they have the support they need in order to correctly build out this platform. So, today we took a look at some of the pros and cons of running containers in prod at scale. And we touched on 4 lessons briefly, such as containers have strengths. Their strengths lie in stateless, ephemeral, disposable processes. And if you already have those processes hanging out in your infrastructure, maybe you're breaking down a monolith into microservices. Consider also putting those microservices into containers. 2 headaches at once. Do it. And you can also put them in testing environments. They really bring strengths wherever you have those ephemeral processes. We also talked about their weaknesses, aka databases, and how people try to be clever, but ultimately end up with either the same hardware footprint with a little more elbow grease, or being network bound. And really, you should just try a cloud provider. We talked about how it's never just containers and how there's a vast ecosystem of software out there that you need to sift through and try and integrate with your already existing infrastructure in order to build this platform. And we also talked about how you need to hire a brand new team in order to build this out, and the different skills you need to incorporate in that team to make sure it succeeds. But at the end of this day, does this really answer your question? You may be asking yourself, okay, fine, but should we use containers in prod? Like, come on. Well, there's no obvious yes or no answer, but there are some indications. For example, do you have stateless services? Do you have a large heterogeneous platform that you would like to bring more in line so everyone's deploying the same way? Do you have the time, the money, the people, the org support in order to make this happen? Then yeah, try running a container platform. It'd be good. On the other hand, if you have a monolith and a few support services, if you have nicknames for every one of your databases, if you have a small team with no org support, if they're just like, oh yeah, you want to do containers? Well, it's you and her, and that's it, and you already work here. Or if you just want to spite me, maybe don't do containers. Unless it's the third one, please. If you want to roll out containers just to spite me, please do that. Please live tweet it at me. I would love that. But at the end of the day, there is a simpler question you can ask yourself, and that's, do you want containers or a blog post? Are containers really the solution to the problem you're trying to solve? If you are making a list of all the reasons to do containers, and reason number 2 is, it would be rad, don't do containers. They're not worth it. It's not worth it. There are so many better tools out there that have the long-term support, that are tested and proven and aren't constantly changing, that will probably work just fine for you. Because guess what? It's okay not to use containers. Containers might not be the best solution for you, but they may be the best solution for you, and so you need to look at them critically to make sure they would fit in with what you're already trying to do, that they really are your best case solution. And if you do use containers, just remember that they can be a little tricky, but as long as you have a good team, you try to have fun, you will get them in the end. Thank you very much.